Greetings. Thank you for joining today's webinar, The Buyer's Guide to Load Balancing Solutions. My name is Rochelle Wheeler, and I am joined today by Andy Redmond, Director of America's Solutions Engineer. Before we begin today's webinar, I'd like to cover a few housekeeping items. There is a questions panel located in the lower portion of your screen. You may expand that panel at any time by clicking the down arrow or the plus sign to see a full view. We will take questions at the end of this presentation, and you are encouraged to submit those questions at any time via the questions panel. Today's session is being recorded, and the recording will be made available at its conclusion. In addition, as a participant, you will receive access to a copy of our white paper entitled Why You Should Perform Security Functions at the Load Balancing Level. So look out for that. I will now hand today's presentation over to Andy. Andy?
Yeah, thanks so much, Rochelle. Hello, everyone. Thanks very much for joining me today on this 2025 Buyer's Guide to Load Balancing Solutions webinar. As was shared, my name is Andy Redmond, and as you can also see from this slide, I'm the America's Director of Solution Engineering here at Progress Software based in Burlington, Massachusetts. I also have responsibility for engineering staff overseas as well, but those engineering staff are supporting the Americas-based business. I have responsibility for our technical sales solution engineers they're really subject matter experts on load balancing solutions, but not just that. It's on-premise cloud-based infrastructure monitoring, forensic level network performance monitoring, network-based cybersecurity with automated remediation capabilities, basically called NDR, network detection and response, and comprehensive scalable automation for configuring, deploying, and managing an org's entire application infrastructure, no matter where it may reside. And for example, take for instance like Facebook, they use our automation solution to provision every single laptop, server, everything globally, massive scale. Progress Software really has some incredibly brilliant technology that's consumed by huge organizations. But anyway, the focus here is load balancing, of course. I'll just make this statement. This is my shameless plug. Progress Software really is your serious one-stop shop for all things app development, app publishing, managing your massive data sets with brilliant and accurate AI capabilities. We got some incredibly unique capabilities with respect to data sets, large language models, et cetera, and having accurate AI capabilities, also compliance tool sets and more. So now that you've heard my brief introduction, let's dig into this buyer's guide to load balancing solutions. The digital transformation journey. I'm going to start off with a brief statement of truth regarding what I believe digital transformation means for organizations and why this particular buyer's guide to load balancing solutions is a critical part of this transformation. So digital transformation means that businesses are relying on their IT networks and applications more to connect with their employees and customers. And these organizations need to optimize what I'll term as the application experience through application availability, agility, and performance. And load balancing technology is a key piece of the IT architecture that's used to create the ideal application experience topology. Load balancers are critical. They ensure that applications are always available through robust application pooling and advanced health checking. And finally, the load balancers improve application performance by using acceleration technologies, including encryption, decryption, and content offload technologies that can seriously reduce server loading. Load balancing is a technology that intersects the world of traditional IT networking with modern application development. And as such, it can be hard to navigate the requirements and expectations for load balancing technology for any given business's application. So this step-by-step guide that I'm going to share with you is designed to help navigate users through the process of understanding their application requirements, identifying their load balancing needs to meet these requirements, and then selecting the right set of features to optimize the application experience. At the end of the day, it's really truly about the application experience that is desired to ensure that an organization can meet the stringent requirements that their customers expect, coupled with ensuring rock solid business continuity. Using the checklist that I'll be sharing in the next few minutes with some additional resource recommendations provided as well at the end, this guide is going to assist an organization of any size to select the right load balancer to fix their requirements. Step number one, identify the business goals of an application. The last thing that you want to do when you engage with any kind of a vendor or partner is to have them just start shoving stuff in your face. They need to understand what your business goals are for your application or your applications before they can have some kind of an intelligent recommendation. And that's part of this journey. It's all about how applications are used within an organization. And we know that applications are what I'm going to term again, the lifeblood of organizations. Without apps, you don't have an organization fundamentally. So they are the lifeblood. Hence, understanding the key business goals is an essential element of this kind of journey. The type of load balancers that is required depends on how the application behaves and what the business requirements are for the application's specific use. So it's important to understand how the application will be used within the business before selecting the required load balancing functionality to meet those requirements. Load balancing solutions should enable organizations to cost effectively scale their operations while also ensuring high availability, right? That's a critical part of this. This creates an outstanding user experience and therefore an excellent customer experience. And that's exactly what we want for our consumers, right? So if you look at what Forrester says, well, according to Forrester research, 91% of enterprises say a couple of things. They say speed and agility in load balancing is absolutely critical. So since the load balancer is the proxy, it's the front door, it sits right in front of the application environment, its speed and agility translate to application speed and agility. Then there's the second part of this, and that's remote working and the need to support 24/7 access to business critical applications and data. And this has been the key topic for most IT teams of recent. Now, ZK research has shown that half of all organizations receive insufficient notification and assistance with mission critical application issues when they happen, of course, which causes unnecessary downtime. So moving forward, the lessons learned about downtime, application lockout, and security threats, along with slashed budgets of recent, have heightened the need for a load balancing solution that's not only secure and quick to deploy, but super easy to manage. But not only that, at a value point that fits future IT budgets. So taking this in consideration, there's numerous key questions that should be addressed during step one. Okay, what are these questions that we need to have answered? Excuse me. I know I'm probably stating the obvious here, but it's important to identify the criteria that are important to each application in consideration here. So what are the questions to answer? That's a great first question. I know I'm cheesy. I'm a dad. I've got dad jokes galore. I'm going to identify 10 key questions this morning that you should evaluate to answer. This is key. So question number one, do you require an application that is continuously available? What's the acceptable length of time that a particular application is down due to faults or perhaps even maintenance? Is there ever an acceptable downtime? How about, is site redundancy required? And if so, for what reasons? Disaster recovery, right? You may have a primary site and a DR site. And the primary site is the site that gets all the traffic, until there's a need to actually have resiliency at a disaster recovery site if perhaps the connectivity to that disaster or to that primary site is lost and you still need to have application availability. Then there's the notion for having active site availability. You may desire to have active to ensure that you can scale as user demand increases. Perhaps that's because you're hosting an e-commerce site, right? And during Black Friday, the increase of sales occurs and you need to have that active capability. Then there's the notion of geolocation for optimized regional content. What do I mean by that? Maybe if your business is located within the United States of America here, you've got a site on the West Coast and you've got a site in the Central and you've got a site on the East Coast. Why is that important? Well, you may desire to ensure that you've got site redundancy for failures at a particular site, but you also may desire to have an optimized user experience. If someone is located in closer proximity to the central of the US, you don't want them going to the West Coast or the East Coast. You want them to be forwarded or directed to the site that's in closer proximity to them so that they ensure that they get the very best application experience with low latency. What about where your application resides? Is it going to be an on-site data center that you manage? Perhaps it's going to be a private cloud, someone else's private cloud, where you're using some kind of virtualized server infrastructure. And then you may desire to have public cloud, take for instance, AWS, Azure, Google Cloud, Oracle Cloud Infrastructure, on and on and on. You may decide that you want to have that hybrid connectivity or even that multi-cloud capabilities as well. Then the next question that you have to determine, this is question number 4, does the application usage vary over time? And do you need flexibility in your load balancing infrastructure to ensure that you can scale as the demand increases or reduce your costs as demand decreases? Is there steady usage? Is there a pattern of continually increasing utilization as success occurs over time, or as you're an M&A organization, so you start to absorb other organizations into your parent organization, and because of that, usage increases over time? But what about spikes at certain events, holidays, start of school, Black Friday, etc.? Then there's question number 5. Are changes made often to the application? Perhaps changes are made every month or less. Maybe changes are made between 1 and 6 months, or perhaps changes aren't as often. Maybe they're made every 6 months or greater. Now, changes within application may change the type of authentication that's required for a specific application, moving from legacy authentication mechanisms to dual factor or multi-factor authentication with SAML or other even more modern authentication techniques as well. So changes that are made to the application will directly impact how the load balancer can interoperate with those application changes. Then question number 6. Do you need to support an identical test and or developer environment as well as your production environment? This is a problem that we see frequently, where customers that are consuming load balancing technology don't allocate the funds for that test or developer environment, and they roll out changes into a production environment without doing regression testing. Humble opinion, that's a mistake. So then you have to determine, do you need the identical test and developer environments for your application environment? Key question there. Number 7, how is the application delivered? Is your application or application landscape purely HTTP web-based? Or if not, what protocol is used for that application, that specific application? Does the load balancer technology that's being leveraged have the ability of supporting those additional protocols? How about encryption? If the application is externally published to the wild, wild web, what are the encryption standard requirements? Are there specific standard requirements? Is there a need to support older levels of TLS, like TLS 1.1 or 1.2? Is a newer one, or 1.3? What are the encryption standards that are required? And again, can the load balancing technology, as you're looking through this landscape here, support those enhanced encryption standards? What about the service level agreements that are in place for your minimum application experience? So parts of that would be, look, what is the acceptable downtime and mean time to resolution, or MTTR, for any given problem that may be experienced in the environment? And then how is it determined when an application is running too slow? What's the tool set that you're using to figure that out? That can be incredibly challenging. And so ensuring that you've got a load balancing technology, right, that gives you the critical insight is key. And then finally, question number 10. Is your application and its data secure? And in addition to that, are there any security compliance requirements as well? All right. So those are the top 10 questions that come to mind as it relates to identifying the criteria that are important to each application that's being considered for load balancing. Okay, now that we've gone through the 10 questions, let's move on to step 2 in the journey. Step number 2, understand the required features and capabilities from a load balancing solution. So the type of load balancer that is required strictly depends on how the application behaves and what the business requirements are for the application's use. It's important to understand how the application will be used within the business before actually selecting the required load balancing requirements. And I made that statement before. So let's invest a few minutes exploring key business requirements so that we have clarity in our focus throughout step 2 in our journey. The infrastructure. When you put the application, or where you put the application, what kind of infrastructure that may be, and how the infrastructure is supported can influence the type of load balancer that you require. Okay, so then what's available? Load balancers are available as hardware appliances for private data centers, on-premise environments, third-party managed data centers. This is a common deployment type when an organization desires to have an appliance that's separated from their virtualization environment. And this may be because they want their load balancers in the DMZ and do not want to expose their virtualization environment into that DMZ. They also may need massive bandwidth connectivity, and they don't want to burden a virtual appliance because of potentially overloading that virtual environment, that virtual host, with a single pair of load balancers. There could be other reasons as well why hardware is desired from a troubleshooting standpoint. But then again, load balancers are available as software for virtual hypervisor environments. This may include VMware, KVM, Xen, Hyper-V, Nutanix, other flavors as well. So that needs to be in consideration. Is a virtualized appliance desirable? What about in public cloud marketplaces? This would be Amazon, AWS, right? Microsoft Azure, Google Cloud or GCP, Oracle Cloud Infrastructure, OCI, Orange. There's a bunch of others as well. IBM has their own. Then there may be a desire to integrate with container orchestration technologies such as Kubernetes. So the infrastructure where load balancers will be housed and the requirements such as bandwidth directly affects the type of appliance that may be selected. Availability and scalability. So load balancers need to be resilient enough to manage application connections even when they fail themselves. They can also offer application scalability by providing more load balancing resources as application demand increases. So there's the notion of active standby, high availability between pairs of load balancers. The active appliance takes the load unless there's a failure, and then the standby appliance takes the load. It could be that in an active standby HA environment that there's firmware maintenance that needs to be done on the load balancer technology for including additional ciphers, TLS cipher, encryption ciphers that have just recently been released to the marketplace. And so there's a need to update the firmware. Having an active standby high availability pair is critical because business continuity for those applications can continue. How about the connection part of it, right? So part of ensuring connections that are flowing through these load balancers are handled correctly is the notion of stateful connection failure to prevent the loss of existing active application connections. This may be in the scenario of like an e-commerce site where I made a connection request through the load balancer to this e-commerce site. I was load balanced to server number 1. If there's an issue between the HA pair of load balancers and there's a failover, I need to maintain my connection to that original server. Why? Because that's the server that I originally authenticated to. So session persistence is highly desirable as well. How about clustering? The notion of clustering beyond a one-to-one availability to deliver high performance scalability. With modern applications, there may be a desire to not just have a typical HA environment where you've got an active passive, but you may want to have a horizontal scaling of load balancer technologies behind a massive amount of servers. And so having an active pair or cluster of load balancers, say 4, 6, 8, whatever, may be highly desirable as well. Disaster recovery. So the notion of having the active standby availability between multiple different sites is part of the availability and scalability topic. And as I've discussed before, active site availability through dynamic global server load balancing or global site load balancing, which is generally referred to as GSLB or GEO, is highly desirable. So availability and scalability are important aspects of any application environment to ensure that during failure events, those critical business apps can continue to function as desired without the end users even knowing there was an issue. And this is the gold standard. Global Server Load Balancer, GSLB, enables the multi-geo, multi-site capabilities and can ensure that users who are actually in closer proximity to a site local to themselves will actually be directed to that site for the best application experience possible versus possibly being directed to a site that is significantly further away, and that's going to dramatically affect the user experience with high latency. What about health checking, right? So this is another feature that should be considered. Health checks are performed by the load balancer to ensure that the application and the server, the underlying server, is working and responding as expected or desired. So moving up the OSI stack means more advanced health checks that provide more feedback. So this advanced health check capability, intelligence, it usually requires more advanced load balancing technologies. And so examples of some of these health checks are as follows. It may be a layer 3 ICMP health check, basically a ping, an echo reply. Is this IP address responding to a question and response? Pretty simple. But then once you march up the OSI stack, we have layer 4 TCP handshake or UDP port availability health checks. You can march up the OSI stack further to layer 7. These are the layer 7 HTTP status codes, i.e., you might desire to get a 200 OK back from an application, or if there's a server issue, you might want to see a 503 server unavailable health check notification to yourself to understand what's happening from the application stack's perspective. Layer 7 can become even more comprehensive with custom HTTP content health checks, such as, look, I want to look for a specific ASCII response. An example could be, hey, look for a down for maintenance message to be returned. That'll give me more insight into what's happening with that particular application. Or there could be just a generic layer 7 health check for any TCP or UDP port. Really, the bottom line here is that intelligent health checks not only ensure that applications are available, but that the client traffic doesn't get what I'll term black holed by reaching an application server that's completely unavailable for responding to user requests, and the user is just left out in the cold. They don't know what's going on with the environment. Their connection is just simply black holed. Not good. All right. We briefly touched on this before, session persistence. Sometimes user connections need to be maintained to a specific server because of local content associated with that particular session. It's also possible that different applications need access to the same local session specific information. Session persistence solves this problem. Different parameters can be used to maintain session persistence for each respective user connection. And so certain examples of session persistence are client IP address. I want to maintain server affinity, persistency with a particular server based upon the actual client IP address. Then there's the TLS, or sometimes called SSL session ID. If I've got an encrypted session with the server, I might want to use that information, especially if my user connections are behind a NATed infrastructure, like on a firewall, and all that load balancer virtual service sees is actually a single IP address coming into it. So maintaining session ID, session persistence based upon a TLS session ID, encryption ID, is critically important. Then there's the notion of web or HTTP cookies and additional HTTP session IDs. There's also the notion of port following for multiple applications, whether that be like a web store or perhaps even a checkout site. If a user needs to have a sticky session with the application server they were originally load balanced to, then session persistence is a key feature that absolutely needs to be leveraged. What about scheduling methods? So load balancers distribute traffic across pools of servers using various different load balancing algorithms, sometimes called scheduling methods, and that's why we've termed this scheduling methods. The best algorithm to use depends on the behavior of the application and the desired experience for users accessing that application. Round robin is good for connections of a predictable fixed length, while least connection is good for variable length connections. Other methods provide benefits for different server capabilities, and that may be weighted, or when connections need to be distributed based on client IP address, such as using an actual hash. So different examples of scheduling methods are round robin, weighted round robin, least connection, weighted least connection, fixed weighting, weighted response time, URL hash. Round robin will send the connections in that round robin manner. The first connection to the first server, the next connection to the next, and so on, repeating the process as the connections come into the load balancer to be serviced. Weighted round robin will distribute connections based on the capabilities of the servers. Two of the servers may get two connections, while one of the servers gets only one connection. This scheduling method is designed to ensure that more powerful servers, they may be newer servers that were just procured, get more connection requests than less powerful servers. So weighted round robin is an excellent scheduling method to use when new server resources are purchased and older servers will eventually be migrated out of the application environment. And these scheduling methods can be changed on the fly depending on the actual needs. What about fixed weighted scheduling? It's usually used in disaster recovery sites, but it can be leveraged for a single site deployment as well. The highest weight real server or servers is only used or are only used when other real servers are given lower weight values. However, if the highest weighted server fails, the real server with the next highest priority number is available to serve clients. Fixed weighted scheduling. The weight for each real server should be assigned based on the priority among the remaining real servers. So when the failed real server becomes available again, it automatically starts receiving requests again. So that's fixed weighting scheduling. Let's talk about encryption features. When applications use encryption, they are usually relying on SSL, which is now known as TLS, or Transport Layer Security. The more current versions are more secure with better and more reliable encryption methods. The current versions of TLS, or the current version, the most current version of TLS is 1.3. Some applications, they really require older version support for compatibility reasons. Certificates are used to manage the encryption keys and are generally unique for each specific application instance. Load balancers can manage the certificates and encryption to offload the heavy performance requirements from the application servers. Why have the application servers respond to encryption requests if they're in a highly locked down secure environment. They don't need to. Let the load balancer that's specifically designed to handle that. So there needs to be configurable TLS. 1.0, no, we don't want to use that anymore. 1.1 may not even use that anymore. 1.2, TLS 1.2, and TLS 1.3. And then there's SSL 2.0 and 3.0. There needs to be support for RSA and elliptical curve encryption, ECC algorithm standards, Diffie-Hellman and other ones as well. OCSP, certificate validation, is important. You need to know that the certificate that's being leveraged is golden. It's trusted. What about server name identification, SNI support? How about support for up to 1,000 different SSL or TLS certificates? What about the notion of automating TLS certificate chaining, making it incredibly simple to import certificates into the load balancer and have them automatically be chained? What about certificate signing request generation? Does the load balancer have the ability within the interface to be able to generate simple CRS or certificate signing requests to harvest a new certificate? Then there's the notion of Start TLS mail protocols such as POP3, SMTP, IMAP, on and on. And then lastly, what about FIPS? FIPS is Federal Information Processing Standards, and a load balancer should support some level of FIPS, like 140-2 encryption certification. Now, with respect to any TLS certificate, leveraging automation within the load balancer is also highly desired and I would say important. The ability of having the load balancer automate the retrieval of robust TLS certificates and cipher sets, and then manage the renewal of those certificates upon a predefined schedule, it's highly desirable. So selecting the right load balancer technology in this journey is essential. Management. You've got to manage those appliances, don't you? The IT operational team needs to support the load balancing solution. They will need to make sure that the load balancer has an easy to use and secure management interface. The load balancer also needs to integrate into other operational management tools, and these tools can be varied as with the functions they provide. And, some examples are as follows: having RESTful and PowerShell API connectivity to orchestrate the entire application environment. Excuse me. How about integration with VMware vRealize Orchestrator? Is there context-based help within the actual system, the load balancer system? How about analytics, providing real-time display of performance and availability of serving connections that are going through that load balancer technology? How about application templates for standardized and best practice configurations, greatly simplifying managing the application environment, deploying and configuring and operating new applications within that load balancing architecture? Then there's the notion of configuration backup. Is it simple? Is it automated? How about when there are issues? Is there comprehensive logging and reporting capable within that platform? Or do you have to use some third-party system for that? Does the load balancing technology support basic SNMP like V2 and SNMP3 modern support? How about authenticated network timing protocol or NTP? Is there a diagnostic shell with inline packet tracing available? So managing the load balancing architecture is critically important. It needs to be simple, but it also needs to be comprehensive from a functionality standpoint so that the various different aspects of ongoing management and operation of that load balancing technology should be simplified. It should be comprehensive. Excuse me. So as it relates to security, inherently, the load balancer does a couple of things, right? It provides application and network security. It's a reverse proxy. So as a reverse proxy, it only allows connections to specific IP addresses on designated TCP and UDP ports, similar to a traditional network firewall. Only those services which have been expressly, specifically engineered and published are available for access. Otherwise, everything else is natively set to deny. It cannot be accessed. Other security capabilities can enhance the application and IT infrastructure security profile. And we'll discuss that topic a bit more in a minute. However, the following functions enhance access security to the load balancer environment. That may be permit deny, extended access control lists, or ACLs. How about IPsec tunnel support to ensure that you can access the environment through that kind of a configuration? What about attack protection? This is typically talked about as a DDoS attack, but attack protection for SYN flood, another layer 4 and layer 7 based attacks. Does the load balancer natively have that functionality built in? Excuse me. The load balancer can also provide enhanced application authentication for more robust application security, but we'll discuss that topic next. Edge Security Pack, ESP, sometimes referred to as AAA. An organization relies more and more on web-based applications, as they do, and the mobile workforce. The importance of secure application publishing continues to increase, right? And so we've talked about ensuring that we've got a robust TLS, a robust SSL TLS encryption applied to the applications. My encouragement to you is to not only seek load balancing technology that supports robust TLS encryption, but it is to seek a load balancing solution that encompasses added layers of security, such as application pre-authentication, multi-domain authentication and single sign-on or SSO, custom login forms, two-factor or multi-factor authentication, that's 2FA or MFA. How about SAML, Active Directory integration, Radius integration, LDAP integration? How about customizable forms-based authentication? And then we've got the historical Microsoft TMG replacement, as TMG is long and gone. All right, what about web application firewalls, or WAF? So with cyber criminal attacks on the rise, and this is a well-published data, organizations need to do more than ever to mitigate risk to their applications that are published on the web. Application security is a multifaceted and ever-changing task, and it must be applied at multiple levels of the infrastructure that serves applications. Security must be provided on the network before requests reach the backend application servers. So deploying a load balancer with the web application firewall or the WAF as enabled as part of your network infrastructure helps deliver this notion of in-depth security for your web servers and applications. Think about it. The load balancer has that privileged spot in that whole application service chain. It sits directly in front of the users that are trying to access that application environment. It literally becomes your control point for all application access. So even if you're not publishing applications to the worldwide interweb, but you have them natively published inside your environment, you should absolutely leverage encryption. You should absolutely leverage a web app firewall, because threat actors do get into your environment. So you don't want to leave the door wide open once they get into the environment. The web app firewall, or the WAF, enables secure deployment of web applications. It prevents layer 7 attacks while maintaining core load balancing services, which ensures comprehensive application delivery and security. The WAF functionality directly augments the load balancer's existing security features to create a layered defense for web applications, which the end result is it enables a safe, compliant, and productive use of published services. As a reverse proxy, load balancers have the opportunity to provide layer 7 content protection, especially for that HTTP, HTTPS, and web content. The WAF can implement policies to protect websites against common and specific threats. So when the WAF is enabled, the WAF, and this is key here to understand, the WAF engine scans every incoming HTTP packet, running it through each assigned rule individually and deciding what action to take if a rule is actually triggered. The rules can be run on requests and responses. Custom WAF rules can be created based on false positives that are discovered. In addition, the WAF enables the following capabilities. It enables real-time application threat mitigation. There's the notion of daily rule updates to these signatures. There's the OWASP top 10 vulnerability protection, PCI DSS support. There's also the notion of blacklisted IP blockage. If the WAF gets a request from a well-known blacklisted IP, then it's going to natively block it. What about SQL injection, cross-site scripting, unvalidated requests and forwards? How about missing function level access control? And then there's the notion of sensitive data exposure to avoid exfiltration. So as you can see, quite quickly here, leveraging a load balancer with an easy to deploy and configurable WAF is an essential part of the toolkit of securing applications that are published to the internet or even internally. Briefly chatted about global server balancing, GSLB or GEO. So sometimes GSLB is called GEO to simplify things. It offers site availability through active DNS monitoring, really intelligent DNS monitoring. There are differences in how GSLB or GEO works, and it's important to obtain solutions that really meet your application requirements in this load balancing journey. Disaster recovery, DR failover for backup sites is what GEO or GSLB can enable. It can enable active configuration for site availability. Truth be told, if you had a single data center and you had 2 load balancers, you could even use that same feature for enabling active load balancers within your single data center for increased connection capability, stability, scaling, etc. Pretty slick. Within GSLB, there's the IP reputation blacklist to block malicious and unwanted clients before they can even reach your application virtual IP addresses, which are the front end, the proxy to your application environment. Geolocation for site direction based on physical location and or distance to the site. In other words, proximity-based forwarding. If you or I are in closer proximity to the Japan data center, then we want to be directed to that data center. We can even do geofencing. If I'm within Japan, I'm only allowed to go to the Japan data center. I'm not allowed to go to London or New York. However, I can configure policy to say, look, okay, I'm within Japan. Japan's closer proximity to me. It's going to give me the best user application experience. Cool story. That's where I want to go. If there's a failure or if there's maintenance needed, yeah, then I can intelligently redirect or forward that session to another site just to ensure application availability. Then there's the capability within GSLB or GEO of customizable IP mapping of clients to primary sites. What do I mean by that? What if the applications are not published externally? What if they're private? What if they're private IP addresses that are actually configured for certain applications that are consumed internally? Well, you can have customizable private spaces that allow you to direct users based upon their proximity to a particular site. And that can be defined based upon these customizable capabilities, such as latitude, longitude that you assign to a customized site. Pretty slick capabilities. GEO has advanced health checking of server and data center cloud health and status as well. So ensuring that you've got a GSLB or a GEO configuration within your load balancer that has simple to use but highly customized capabilities are really important. GEO is slick because it offers the ability to move past a single data center. It allows for multi-data center high availability. And even when the primary site's down, traffic is directed to the disaster recovery site. Also included in GEO is the ability to ensure clients connect to their fastest performing and geographically closest data center. GEO ensures that mission critical servers are continuously available and performing reliably. GEO can monitor server and application load. And this information is then used to intelligently direct user requests to the cluster, the application cluster that's most available to them. So by intelligently redirecting traffic, the load balancer eliminates server overload conditions and round-trip propagation delays that may slow performance, allowing you to increase end-user application speed. GEO solves also the scalability dilemma in the common adage, and I quote, "Growth is the challenge, scalability is the key," close quote. GEO solves this by continuing to support increasing network server workloads while still providing high availability. By the way, if your applications are only on premise today and you want to do that hybrid cloud environment or move to another site, do something in GCP, AWS, Azure, etc., then using Geo to manage that that expansion into those environments is super duper easy. Geo needs to be easy to set up and it needs to be easy to manage. So when network management is made easy, administrators can deploy new servers and take individual data centers offline for routine maintenance without disrupting services to end users. End users can be completely oblivious to these actions. So integrating Geo into an existing DNS infrastructure, it literally can be done with no service impact, and it allows for distributed administration, which is pretty slick. It's important to achieve a clear understanding of the required features for site availability and site performance. That's going to allow you to pick the right solution that won't underperform or offer additional non-useful features to maintain. Okay, now that we've discovered business requirements and local load balancing features to address those requirements, let's move on to step number 3 in the journey. Step number 3, licensing options. What you want to pay versus what the CFO wants to pay for a load balancing solution may differ greatly. So your key here is to use step 1 and step 2 before looking at pricing. That's going to provide much needed arguments or reasoning to get the purchase complete, right? It's going to tool you for that business case. Step 1 and step 2 tool you with key data necessary to build a robust business case for upper management. So the method that you will consume and pay for load balancing services is another item that you need to identify when determining whether the price you find is acceptable for your project's requirements. And there are multiple ways to obtain the solution that you need. So let's look at options that you should consider in your decision-making journey. The perpetual license option. So first, there's the traditional perpetual license. This is a license to purchase the solution outright, whether it's a piece of hardware or an instance of load balancing software, a virtual appliance. The license is usually based on the maximum network throughput the product can support. The perpetual license does not include support services nor software updates. The support services can also include access to additional functionality. Hence, all you need to do is purchase the load balancer appliance and add support. The perpetual option is a well-known purchasing strategy that many organizations still love and appreciate. We have customers that buy 3 years or 5 years of support because they're putting it behind an object storage type of infrastructure, and that's what their other object storage vendor provides: 3 or 5 years of support, or maybe even sometimes 7 years. And so there's specific discounts when you're looking at your support subscription and how you're going to structure that. How about subscription service? The subscription service option. Second, you may consider a subscription service. The business gets access to the product and support for a payment on a regular schedule, which is usually on an annual basis. The subscription provides full access to the solution and features without the initial upfront payment required with the purchase of a perpetual license. This is attractive for some organizations. Excuse me. Then there's the pooled license option. Third, there is often a pooled option where a company can purchase a certain amount of capacity and then distribute it throughout their environment based on their specific needs. This is a beneficial model when there's a need for multiple load balancers, and the needs can vary based upon applications and time. You may decide that you want to allocate an HA pair of load balancers to one BU in your organization, and another pair to another BU, and another pair to another BU. One pair in the DMZ, one pair in the LAN infrastructure. Pooled is fantastic for that. How about an example where a company may require and they may acquire a 100 gigabytes a second of pooled, and they can then distribute that into individual instances as long as the total capacity stays within 100 gigabits. Capacity can be distributed and recovered as long as the pooled license is valid. And this is typically paid annually, similar to subscription, but it also includes support services natively. So pooled subscriptions are annual. They're billed annually. Subscriptions include 24/7 support, identity and access through Edge Security Pack, the AAA functionality, the Web App Firewall or WAF, and Global Server Load Balancing, GSLB or GEO. Those are the functions that are natively included. It's a one-stop shop for the pooled resource. Regarding pooled licensing, the following questions and comments, the following questions, comments, and answers can assist an organization in making the very best decisions on this journey, right? So, for example, I want flexibility to deliver capacity when and where needed. Pooled licenses are on demand, so you can deploy a new load balancing instance or relicense an existing instance without any procurement process. You never need to talk to the vendor again. That's a glorious thing, right? You need to make a quick decision. You don't have to fiddle around with a vendor or a partner. You can just make that decision on the fly. How about I need to be able to scale on demand? Automation capabilities and API support, deployment and licensing using toolsets such as Chef or Terraform. It allows automated scaling of services to meet changing demands. So automation is key here. I use both cloud and on-premise platforms. Pool licenses can be issued to any load balancer on any supported cloud or on-premise hypervisor, which allows a single pool to deliver capacity across hybrid environments. Why would you want to do that, like in a hybrid environment where you have on-premise and then you have a cloud base? Well, sometimes organizations say, look, okay, public cloud, it's got a built-in load balancer. I'm just going to use that. How do you deal with the SLA? Provisioning it, configuring it? What happens if you have a troubleshooting instance and you actually need to troubleshoot? Is this an application issue? Is it a client issue? Is it an underlying host issue? Is it the load balancer that's causing the problem? Do you have the tool sets built into those cloud-based load balancers to help you troubleshoot? No, you don't. There are no tool sets baked into those cloud-native load balancers. They're very vanilla in their functionality. So yeah, you can publish a service, but so what? Your SLA is completely messed up. You do not have a standard SLA on your on-premise and your cloud-based environments. You can solve that with Pooled, where you distribute the load balancers based upon need in whatever environment that you want. It's really a glorious story. All right. So then there's the question of the comment. Look, I want to cost-effectively add a security layer to all my applications. Web App Firewall functionality is available for specific Pooled subscription tiers, and it can be distributed and managed through LoadMaster 360 as an example, right? I want to be able to control how much bandwidth is used by an application. That's key here, right? Licenses can be issued from the pool to either have multiple applications per load balancer or distribute specific applications to their own load balancers. Doing this allows specific control on bandwidth allocation. Why is that important? If you're doing hybrid cloud or multi-cloud and you've got some of your pooled load balancers sitting in public cloud, you need to be able to manage the spend, that operational spend. And if you can dictate that by putting specific constraints at the load balancer level, either from the sizing of that load balancer that's been provisioned or the quality of service that's natively integrated, if that load balancer technology has that, like the Progress Kemp Loadmaster does, then you can engineer that desired throughput level. Fantastic capabilities. This is something that should be considered. So, as you can see, the pooled licensing model is extremely attractive because it enables great flexibility from a feature and functionality perspective, but it also enables flexible scaling capabilities as user demands shift and changes. You can turn on a load balancer like a light switch in that pooled model. Turn it off like a light switch. It's fantastic. Okay, so we've looked at a selection of different licensing models. Let's move on to step 4 in this ongoing journey. Price versus value. Not all load balancers are priced the same. I think that's fairly obvious. and different vendors charge different amounts for certain functions and capacities. During the pricing process, it's critically important to stay focused on the project's requirements. The business requirements are what I'll term the leading indicator. It's the leading focus that should be considered when you're looking at different kinds of vendors to procure your load balancing technology. An application delivery controller, ADC, is essentially a load balancer with enhanced extra capabilities like the web app firewall, the GSLB or geo capabilities, the edge security pack for pre-authentication and single sign-on, etc. But not all load balancing projects require all these functions. So flexibility is really important. Excuse me. You should prioritize the features that your application project needs to be successful. Don't be distracted by the shiny lights or fancy features that you probably do not need or won't ever use. So when you're doing the research, compare different vendors' products and make sure you are making as equal a comparison as possible between those technologies. Price and feature comparison. So looking at the top load balancing vendors as rated by Gartner, the following is a price feature comparison for a sample of their offerings. So option number one. Option number one compares the ProgressCamp LMX15 NG, next generation hardware appliance, with the F5i 2800 hardware appliance and the NetScaler MPX 8905 hardware appliance. You can clearly see that the ProgressCamp LoadMaster costs a nominal $11,000 and supports 15 gigabit a second of throughput. The F5 load balancer costs approximately $28,000, more than double, and only supports 10 gig of throughput, a third less. And the worst of the three is the NetScaler load balancer, with a massive cost of $44,000, supporting only 5 gig. I mean, that's crazy. At a cost of 4 times that of the ProgressCamp load balancer, the NetScaler is 3 times less performance. Those cost and performance dynamics, to me, honestly, are amazingly compelling. Then we have option two. It compares the ProgressCamp LMX3 NG hardware appliance with the F5 Virtual Edition 3 gig appliance and the NetScaler Virtual 3000, which is a 3 gig appliance as well. So for the same throughput capabilities, the ProgressCamp load balancer offers substantially more capabilities for a fraction of the cost of the other two solutions, at literally 10 times the cost for the other two. That's rather staggering, in my opinion. Why are they charging 10 times the cost? Why are so many customers leaving those vendors for other solutions? Good questions. Summary. Gathering this information and the requirement for your load balancing project is just the first step in the process to identify and select the best solution for your needs. Each project and application have different needs based on your specific business goals. That's the key right there. The specific business goals dictate what the requirements are. It's important to understand and select the features that you need to support those business requirements while avoiding the unnecessary and potentially expensive extras that you may encounter. This buyer's guide provides the basics, just the basics, to allow you to start the selection and acquisition journey. To validate your choices, you need to compare your choices with those from third-party and customer review sites, such as Gartner Peer Insights, that offer insights on the ADC load balancer market. Look for customers and projects that have similar goals and or are in the same business vertical as yourself. If you're in the financial space, look for those that are in the financial. In healthcare, the same, right? The selection of any technology is not an easy process, right? It's essential that you ensure that the chosen solution meets the needs of your business and specific project. This needs to be done with an understanding that the cost, the complexity, and the support of the technology does not become a barrier to the effective use of the solution. We hope, and I hope, this buyer's guide helps your journey to selecting the optimal load balancing solution to optimize the application experience for your applications and your IT organization. Glossary of useful research. So, as I noted at the very beginning of this presentation, please see the following additional resource recommendations that will assist you in your quest of finding the very best load balancing solution for your digital your digital transformation journey. If you'd like these links specifically, or any additional detail or further discussion about anything I've discussed here privately, email me directly or post your question in the appropriate spot in this webinar per previous guidance Rochelle provided, and I'll be quite happy to remit back to you. Okay, lastly, my shameless plug. This is number 2 shameless plug, because I genuinely really do care. When you think about your specific digital transformation journey, think of Progress Software as your essential partner in that journey. Why? What you'll see reflected in this graphic is a high-level overview of the comprehensive solution toolset you'll have access to for your end-to-end application infrastructure environment, not just load balancers. Everything from building mobile and desktop apps to engaging website construction and publishing to serious business logic, decision trees, and analytics is included. You'll be able to enable document centric collaboration and manage your relational and multimodal databases. You can unlock your data value, accelerate insightful decisions, and securely achieve digital or data agility. You can combine your data with everything known about it via metadata in a single service and reveal smarter decisions faster. You can capture enterprise knowledge that will become simple by analyzing structured and unstructured information to extract hidden facts and relationships and classify subject matter so that it can be integrated across your technology portfolio. This enables your organization to accelerate automation, insight discovery, interoperability, and data sharing across systems. And finally, you'll be able to orchestrate your entire application landscape and forensically understand, I mean, really forensically understand all aspects of that landscape with full stack observability at the endpoint, the node, and the network levels. You're literally only scratching the surface with the Progress Kemp Load Balancer platform. Let's have a follow-up discussion to learn more about your business challenges. All right. Thanks for your time. This is your opportunity to ask questions and or make your comments.
So Andy, we're running over on time a bit, but I do see one question here, and it's a question in regards to modeling, and evidently the question is, we have peaks and valleys with our volume in our application. In terms of like pricing and a consumption model, which should we choose? Like, which is better, pooled or perpetual?
Yeah, fantastic question. One of the things about perpetual is you're locked in, right? If you buy a perpetual virtual or you buy perpetual hardware, you're locked into the capacity of those specific units. This is why a pooled model provides that necessary flexibility. If you need to increase bandwidth, you can do that, right? You've got the ability to do that in a very flexible and scalable manner. So it really depends. Sometimes the business decision is smarter to buy just a little bit more in a perpetual appliance to meet the required, peaks and valleys based upon some historic analysis. Then other times it's much more flexible and a better decision and a lower cost decision long term to have that more operational model of scaling with a pooled model. So would love to chat with you more about that. If you want to have that dialogue with me, please reach out. We've got your contact details. I'm happy to have that conversation to make it more robust as we examine different elements within your decision making process there.
Thanks, Andy. I have another question for you. Few customers have files upload process within their applications. Um, we are seeing that the competition has a feature called ICAP, So the ADC would extract files and send to a third-party security solution, such as an antivirus. Does LoadMaster have such capability?
That functionality is not baked within the LoadMaster load balancer. No.
Okay. Looking to see if we have any additional questions. Nothing else here today, Andy.
Well,
So,
wonderful. Thank you very much, guys.
yeah, I would like to thank everyone for joining us today. And again, you will receive a copy of this recording via email. And you'll also get access to our most recent white paper, Why You Should Perform Security Functions on or at the Load Balancing Level. We thank you all for joining us and have a great remainder of your day.